Hey everyone, so let's give you one more example here of a thorough, well, mostly thorough Matchbox recommender example. So far, if you've been following along, you've learned about the different scoring methods in 15.2, how to do an item recommendation versus related items, related users. In 15.3, you learned how to include or incorporate user and item features, so information about the customer, the product or service, or it could be another customer that's being rated. You also learned in 15.4 how to incorporate text analytics to hash text into features about the Amazon product in that case, but you could also hash text into features about the customer who's doing the rating as well. Now I want to take a real-world example from this study right here. So this was a Kaggle competition about a year ago. Let me pull it up here. There's a website called donorschoose.org. I've used it before to donate to elementary schools, middle schools, and high schools that my kids go to. When the internal funding doesn't come through for what they need, teachers can propose a project or submit a proposal to this website and ask parents or others to consider donating to the project. So, for example, a music teacher wants 10 instruments. They submit a project on here, write up a short essay on it, and people can come and donate. This not-for-profit organization is hoping to improve or increase donations by recommending related projects to people who've already donated that they'll be interested in donating to. So it's a perfect example of a Matchbox recommender. We've got projects with multiple people donating and people who've made multiple donations. So it's got this nice built-in association or linking table, which is the format we need for a recommender algorithm. So let me show you the data sets here. I went through and I've spent a lot of time to download and actually clean them up and get them ready. So I'd recommend using the version right here. So I've made it's a huge data set, and I put it available in a private box folder that anyone can download. I'll add a link to this in the description of the YouTube video as well for those that aren't in the class. But I would highly recommend using my version instead of theirs because I've gone through and removed and cleaned up a lot of the data. There's line breaks, commas, and other things that create problems when importing this into Azure or a SQL Server database. So if you use the one I've made, you'll have far fewer problems. So let me explain what we've got. Here's the donations table. This has our record of the user item rating triples plus a little more information. Donors, these are our users, or the people doing the rating, and this is features about the donor. Projects, this is the main class or object referring to the ratee, or what is being indicated preferences for. So it's the item in this case. Now, if I'm donating to a school, it could be because the project has resources that I like. So in the music teacher example, the purpose of this resources table is to list out everything that the teacher's looking for. So all 10 for one record here in this table, in the case I gave you, there'd be 10 records in this table for each of the instruments that I want. So this has more features about the item being rated that could be useful. I may also choose to donate because I'm invested in the school. I'm maybe on the advisory board, or I just like them a lot. My kids have all gone there, and I want to donate because of features about the school. So this table has information there that could be useful. It could also be that I simply like the teacher. They've been a good teacher, and I want to support them. And so here's information about the teacher that could be useful. So here's my user item rating triple, user features, and then all four of these have item features. And we're going to need to connect the dots between all four of those tables. All right. So let's go ahead and build this experiment. Now, because of how large this data set is, it's gigantic. It's all of the donations ever made to this website. Well, actually, no, I take that back. I think it goes back to like 2013 or something, which is big enough to make that projects table 2.4 gigabytes when it's unzipped, something like that. So I'm going to pull my data from a combination of CSVs I've uploaded as well as an import data from Bill from SQL Server for the projects table. So let's start here with donations and take a look at that and see what we're working with. Okay, so our user is right here, donor ID. Our project, the item being rated, is right here. And notice we're going to have both of those listed multiple times. So here's the same project ID repeated right to here. 6 donations made to this project. 6 different people in this case, but the same person could appear across many different projects, or even across the same project multiple times in some cases. Donation ID is the unique primary key for this table, but it's actually irrelevant to our needs, so we're going to ignore that one. Donation includes optional amount. This means, did this donation amount right here include a portion that was intended just for DonorsChoose.org to support the not-for-profit website? That could be useful in explaining why they donated this amount. Cart sequence. This refers to where the project appeared on the web page. So there's a known human psychological bias that we prefer or gravitate towards items that are higher on a list or earlier on a list because of fatigue. We ignore those that show up later. It's the whole reason that the field of search engine optimization exists. When people search on Google, they naturally gravitate towards the top records. So knowing where this project was listed on the page at the time it was donated to could be useful in explaining how much or whether it was donated to. All right, let's begin with a simple select columns. Actually, no, not yet. Let's pull up the projects table. I want to show you something. So I'm going to need the import data pill. Import data, there we go. And let's connect to my SQL Server database. Or if you just imported the CSV, just pull the CSV out here instead for the D_projects table. Because I've used up a lot of my Azure space, I can't do that. I've got to pull it from SQL Server. Databases. I think it's database. We'll find out. I can never remember. IS415, IS415. Now, you're also welcome to connect to this if you're in my class. If you're in my class, then you'll know the password I've given out for this server to use. And I'm going to say, for now, just select the top 3 only of everything to see what I'm working with here from D_projects. I know it's not case sensitive, but I can't help myself. All right. Okay, perfect. Let's, now if I run this, it's going to eliminate the donations table. So I think I better go ahead and pull in that select columns pill after all. Come on. Select columns, there we go. Otherwise, if I run it with a data set that's not used, it will often just eliminate it. Not always, I haven't been able to figure that out. So, I'll go ahead and just pick my user item rating triple. So I need user is the donor, item is the project, and rating is a donation amount. And I need to make sure that they stay in that order, so I come in with rules and I check the allow duplicates, which I actually don't want duplicates. I just have to check that because I need to preserve the column order. We'll handle duplicates in just a minute here. Okay, let's go ahead and run this. I'll pause the video while it runs. All right, let's see what I did wrong here. Whoops, no, zoom out. Invalid object name. Oh, it's not .csv. I'm sorry, it's just .projects. All right, run selected. Okay, while that's running, cool, that one's worked. Let's take a look at this data. It should only take it a second here because I'm only pulling 3 records. A bit of advice, if you're pulling this data into your own SQL Server, don't forget to create a primary key and add an index. It'll save it a lot of time on queries, making sure you have those. Okay, so let's take a look here. Check cache results, because otherwise you lose that checkbox. It's a weird Azure thing. I lose my green checkbox and the ability to look at the results unless I check that used cache results. I don't want to cache it permanently because I'm going to come back here and tell it to select a whole lot more than this, but just to view the results, I forgot I have to do that just to start out. Okay, let's take a look now. Visualize. So I've got a project ID, the school ID, teacher ID. So here's that's how I'm going to hook into those other tables. Teacher project posted sequence. So that's where that appeared on the web page again. I've got this project type, whether it's teacher-led or something else. That would be useful. Here's a bunch of text we're going to analyze and include. Project title, essay, short description, need statement. Boy, all kinds of text we could get into there. For this video, I'll probably just stick with something simple like, I don't know, I like need statement, but maybe I'll do the short description. Here's the subject it's in, subcategory, so kind of a higher level, lower level. The grade level, project resource, what type of resources they're looking for, total project cost, posted date, expiration date, current status, whether it's fully funded or not, or if it's expired. So if I'm going to recommend to people what type of project to post to, if I'm going to recommend projects for them to contribute towards, I don't want something that's fully funded or that's expired. It's got to be something that's current. Okay, so close that out, and here's what we need to do here. On this import data pill, we're going to add a couple of criteria. Select top 3 from projects where current status not equal to fully funded, not equal to expired. Now another way I could do this is add a split data pill and pull that in, and let me give you an example here. If you're using the CSV, I could pull this in instead, and I could use a regular expression split to say project current, if I could spell right, current status equals either fully funded, pipe means or, expired. And what that would do, it would send the fully funded expireds out the left and anything that's not those out the right, and I could use that data set. But I'm just going to keep it, since I'm already pulling from SQL, or you could actually, if you're using the CSV, you could pull it in and apply SQL transformation pill and use that instead, and then just copy my SQL here to, except instead of pulling it from D project, you're pulling it from T1, because that's what we would call the table coming in. Anyway, let's run that one, and let's see what we get back and see if it makes sense here. We need to pause this. All right, let's see what we have here. Results. Okay, live, perfect. That's what we want. So as I guessed, like I thought, there's only 3 statuses. There's fully funded, expired, and live. So let's not deal with any donations that aren't having to do with live projects, because we don't need a massive amount of data for this recommender to work and to be accurate. Let's go ahead and scope out anything that has to do with anything that's not live. So a couple things we want to do. We want to make sure that we don't get any donations out of this table that don't have a corresponding project that's live in this table. How do we do that? Well, that's where we can get smart and use something like the join data pill. So here's what we're going to do. Let's make some notes here. This is our user item rating triple, and it's going to be in the form of a donor ID dash project ID and donation amount. So I like to keep notes. One, help us remember what we're doing, but 2, what if there's some way we want to modify rating in the future? Maybe we discount it based on those include ratings to donorschoose.org or something like that. So just keep my notes here as I go along. Okay, don't worry about that. All right, so what I want to do next is pull both data sets into here. Now I'm going to need to change this to select not just the top 3, but all from projects where, and since we know that status is live is what we want, that's the name of it, I'm going to, well, a couple things at once. First of all, let's designate the primary key foreign key relationship. So we want project ID from the donations table and project ID from the import data results set that we have here about projects. However, I also want to come in here and maybe, I don't know if this will speed it up or not, but I'm going to say, rather than say give me project status that's not equal to those, I'm going to say give me project status that equals live. And instead of top 3, I want everything. Now I might pare that down later, but let's go ahead and get that now and cache the results, and then we'll worry about getting rid of columns in a bit. So I'm going to go ahead and get this running and pause the video. Okay, so we've got this done, and here's what our join data is doing now. Let's take a look at the result set. All right, so we have the same things we had before, but what you'll notice is we've joined our donor, project, and amount to the projects table, but it's only now for projects that are currently live. So it's a big long list. It only shows us the first 100, I think, in this list. But now we're only going to include the triples of donor project amount for those that people can actually currently donate to, and we're ignoring the rest. So in machine learning, this is common. It's the big data problem applies more to data mining, where we're trying to just aggregate all data and visualize everything. But in machine learning, when we're predicting something, there's often an expiration point with data where we don't want to include it anymore in our predictive model, and we don't need massive amounts of data to do this. And so this is a case of that being applied. So what I want to do now is actually flip this. So rather than have multiple select columns, what we want is to, there we go. Let's select columns after we do the joining, because this is the one that's going to reduce it down to the donor project donation amount. And if I put the join data up here, I can eliminate all projects that are not live and then save myself one extra pill. All right, so let's keep going. Now that we've got the columns we want only for live projects, let's take care of the problem with duplicate donations to the same project. So to do that, let's get the apply SQL transformation pill that you may have learned in the prior video. So let's pull this in. The way this one works, as a reminder, is it calls the input dataset T1, or it calls it table 1. And we're going to say, instead of saying select all, we're going to say, let's see here, we want, and actually, you know what? I think we can get rid of our select columns at this point too. Here's why. We're going to select donor ID, project ID, and then we're going to sum donation amount. And so we can actually accomplish the same thing without that select columns pill. So let me show you what I mean. We're going to get donor ID, and the nice thing about SQL is it's going to select it in the order we put it in the select list. So it's going to maintain column order like we want. Donation ID, project ID, and then we want to sum donation amount from T1, and then let's group by whoops, undo, I meant to do command copy. There we go. Group by donor ID and project ID. So what it'll do is it'll find every instance where the same donor has donated the same project. It'll sum up those donations into one record with one donor ID, one project ID, and the total sum of all their donations. So now the data is in a format that it's almost ready to be used in a bare bones prediction. But we're still going to have a situation where donation amount is often over 100. Let me run this and show you what I mean. By the way, while it's running, I thought I might show you what we've changed to. We've gone down from, I think there was 5 million total projects to, after we've selected only those that are live, we now have 41,851 projects. Still quite a few. And truthfully, I don't think we need that many in order to make this work. So, although I'm going to keep all of the data, if you want to speed things up and not have to wait for your project to run each time, you could grab the partition and sample pill, pull that one in to import data, and reduce the amount that's being joined with donations to something smaller, like 5,000 or something like that. In fact, maybe I'll do that too, just to make this save some time. Yeah, let's do that. So I'm going to grab partition and sample, and I'm going to pull the output of that into the join data. And let's tell this we're going to sampling, which is going to grab a random sample of, and let's go ahead and let it, no, let's leave that. Let's get from 41,000, let's go down to 5,000, so that'd be 10%, maybe a little bit more, maybe 12%, that's good. I'll stick with a random seed, and now let's run to that point. Okay, let's take a look here. Results data set. All right, cool. Donor project. Oh, you know what? We should give that. Well, no, that's okay. We don't need to change the name. We can just leave it like that. So here's our problem. We still have some donations that are over 100. And there's quite a few of them, actually. So we got to scale that down. What's a good way to do this? Well, let's click on this column and see. Okay, here's the histogram. So this says that almost all of our donations are below 2.0e plus 0.2, so almost all of them are below 200. Very few are much higher than that. So I think a natural log transformation would be good, because natural log is the opposite of this long tail. It's the inverse. So it decreasing increases. It converts it to that. So that's the perfect thing to offset data that looks like this. So let's do a natural log, but that's also going to give us a couple problems, because a natural log will result in decimals, which we also can't use. So, but one thing at a time here. Let's apply math operation. Pull that in here. Okay, and we want to round, no, not round yet. We want to do some basic, here we go, natural log. So this natural log plus 1 is super useful. In this case, it doesn't matter, but what it does is in situations where you have a rating of 0, we don't have that here because all donations are at least $1 or more. Or are they? I wonder if people can do a donation of less than $1. Actually, you know what? We better do this one. What it does is it adds 1 to everything, because natural log of 0 is undefined. And we don't want to lose any data that they've donated like less than 50 cents. Who knows? But let's just do this for example's sake. But what we can do is add 1 to all records. And it still maintains the same spread because it's added the same number to everything. But what it means is the smallest records will no longer be zeros that are undefined. When you do a natural log transformation, they'll be 1 plus whatever little amount that was. So let's do natural log plus 1. In this case, yeah, on all numeric columns is fine because there's only one numeric column. But yeah, I don't like doing that. Let's just go ahead and select the name. Some donation amount. Okay, now that is going to give us a rounded number. So let's pull in another one. And you know what? I better do a better job of taking notes. So the reason why, again, I think I may have, in case I forgot this earlier, this join data doesn't inner join. So what it does is it says only give me records in the donations table that have a matching record over here. So by reducing the data set down to only live projects, it's only going to allow us to collect donations from projects that are live and in this smaller partition sample. So I'm just going to make a note of that here. Only include live projects. That's the purpose of that join data. Add a note. And that's again because we have the inner join. It means there has to be matching data on both this table and that table in order to keep it. It also, that's useful because it'll make sure that there are no donation records that don't have a matching project, which would create a problem later on. So that's a useful technique. Apply a SQL transformation. This is some multiple donations from the same donor for the same project. Cool, got that one. Now, ln transformation. Now we can round in a few ways, and actually rather than use the apply math operation gives some cool rounding options. Whether you want to round up or down, do a mod, round to the nearest even or nearest odd number, simply truncate and don't round at all. Another way to do this is to just use the edit metadata pill for just a very basic rounding, because we can say convert this to, instead of a float, into an integer, and it'll just round up or down appropriately. So I'm going to say round to nearest integer. Now, given that if you understand natural logs, you know that it has that effect of making higher numbers more similar. So large donations are going to be we're not going to differentiate well between large donations. Every context is different, and that could be a problem in some. I'm okay with that here because donations are so heavily influenced by income or by how much money the person actually has to donate. In the lower ranges, everybody can donate a certain amount, and so Natural log is good because in the lower ranges, it differentiates well between those. But as the numbers get higher, the difference between a person who donates 1,000 and someone who donates 10,000 is probably just disposable income. And it's not truly how interested they are in the project, or at least to a lesser degree. So I don't mind natural log doing a worse job at differentiating among larger donations. But that's just a business decision that you can make. So edit metadata, let's select that column, sum donation amount, change to an integer, we're good there. I think we're good to go at that point. So let's go ahead and split data. Come on, learn to spell. Split data again, split only applies to our triple. We need a recommender split, randomize 1, 2, 3, 4, 5. I'll leave those defaults because we have tons of data. Then let's grab our train score and evaluate. Make sure it's train recommender, not model, and same thing with score and evaluate. I make the mistake all the time still, even after I've got experience with this thing, of accidentally grabbing like a score model or evaluate model. And of course that'll break. It has to be the recommender. Okay, let's pull in the dataset to score from right here. This is the test dataset from right there. And let's start with a rating prediction to get our RMSE score. So I've got my Excel document here to track all my models. So here's what I'm going to do to keep track of things properly. Triple, this is going to be donor ID, project ID, sum donation amount. I don't have to spell the field names properly with the spaces here. I'm just tracking what I'm using. So for my first model, NA, I'm going to get an RMSE score in a moment here. I'll just keep track of that. Okay, let's run this and see where we're at. Okay, so my process stopped with an error here on edit metadata, and you probably got that too because I always forget right here. Whenever we apply a math operation, it has an output mode, and by default it's set to result only, which means ignore all the other variables that were coming through, like donor ID and project ID, and instead only allow this modified natural log +1 sum donation amount column through. That's not what we want. We want in place. That means modify sum donation amount in place and continue to return all of the other columns that were coming through. So once we do that, it should work fine. We're still converting sum donation amount to an integer. I decided, let me just give it a new name while I'm at it. So I can get rid of that sum donation amount right here. It's not really necessary though. And let's continue this running. And hopefully it'll make it all the way through this time. Okay, everything looks good here. We've got our split data worked, our train Matchbox recommender, scored rating prediction, so we should get an RMSE score out of this whole thing. All right, here we go, 1.69. So what that says is that on average, we're going to be only $1.69 away from their true score, which is really pretty good in my opinion. I'm going to take that number and let's record it right here for this model. So this is our no user, no item features RMSE score model. That'll change once we add those. But I'm going to go ahead and get my scores for each of the different types of predictions. So I'm going to add in here a insert scoring method. Actually, no, it's not called scoring method. What should I call it? It is recommender prediction kind. Okay, fine. That's kind of a weird name for it, but we'll use their name. There we go. Recommender prediction kind. Is that a different format? No, I guess that's it. Oh, there we go. Recommender prediction kind. So this is a ratings prediction, which we use just to get RMSE. So now let's do our item recommender. Item recommendation. That's it. I always forget that. Recommendation, related items, and related users. All right. And these are going to be not applicable because we don't get those for those. We get NDCG scores, and that one's not applicable. All right. So let's go through and run each of those. That's always what I do next to get my baseline model. Although, one thing I could do to get different types of models, it may be worth saying, okay, back here on the train, number of traits. I've talked about this in another video, but let me mention it again now. This says that let's use the top 10 donations for every person. So some people will have made less than 10 and it'll use all of them. Some people have made more than 10, and that's where this applies. It says, okay, if someone's made 20 donations, let's only use the 10 that are most common among all other donors. Well, that's useful because it could be that the other 10 of my donations are to these weird, spurious sort of projects that people who are like me wouldn't normally want to donate to. It's because I have a personal relationship with this teacher or school or resource that I'm donating to. So we may get a better score, in my opinion, by turning this way down to maybe only, I don't know, the top 5, maybe even only the top 3. Let's see if that changes things at all. And I'm going to add that. Insert right here, traits. It's something to keep track of. So this first one was a default 10. And I'm going to now include, copy all these down. Those are NA. Traits to 5, and let's see what RMSE we get. All right. Oh, whoops, that's my, I accidentally changed away from ratings prediction. Since I've got it though, I may as well just go ahead and include it. Visualize. This was 0.9365, so I'm going to copy that and put it right here for my item recommender. Remember what I got. And let's change this back to a rating prediction. Okay. Since these are all the same, I think I'd prefer to leave them blank as long as they're the same, and then I only will enter them once they're different. This is almost done. There we go. Metric visualize. That got better. I'm not surprised. I think people often don't donate a lot, in my opinion, and so it makes more sense to include a smaller number of the top donations. And now our RMSE is lower, which is good. We're only $1.45 away on average. Ooh, I kind of want to try it one more time and see if it keeps getting better as we go down. That was only 3 traits. We do top 2 traits. Let's see what we get with that one. So actually this one was 3, not 5. And this one's 2. I kind of don't really care about all these NAs. Well, maybe it helps. Okay, looks like this is done. Let's take a look. Even better. Okay, 2 is the minimum I want to keep. So here's the trade-off by doing that. By lowering that number, yeah, I'm more accurate. However, it's going to be harder to recommend. Oh, whoops. I didn't copy that quite right. It's going to be harder to recommend projects that are different, and it's going to push everyone to the same few projects. Well, that may not be bad in this case, and here's why. Because at some point, a project becomes fully funded. And when it does, oh, it's because I didn't do Format Painter. There we go. And once it is, it's going to come off the list anyway, once it's fully funded, and it's going to push them to some others. So I think I'm okay with that, keeping ratings prediction nice and low. So, but it also higher potential for overfitting the model. So this is a judgment call. I'm just going to leave it there for now. So let's do this next. Let's go through and get our, now that we tweak this, I'll have to redo it again. Let's grab our NDCG scores for each of the different types of, the other 3 types of production predictions. So this is the context where, and we always do this for rated items only to get our NDCG score. We leave that right there. So let's run evaluate. So I always go through next and grab this score for each of these three things. Again, I haven't messed with user or item features at all at this point. Okay, so when we're done here, item recommendation gives us this NDCG. Let's grab it. I think it's the same. Wasn't affected. Okay, no problem. Format paint. So let's go ahead and get the other ones next. Related users. We always keep it to for users that rated items for model training only. Leave that to the default each time. All right. But coming up next, we're gonna. Oh, I think we're always gonna keep those three. But now we're gonna, after we get these two scores, we're gonna add user and item features and see how these numbers change. All right. Let's see this one. So here, oh, not N1 and N2, it's L1 and N2. Sorry, L1 and L2. Change those. Okay, let's get the next one running. Change it from related users to related items. Okay. Do my format painting thing while I'm waiting. I really don't need more than 3 decimal places. All right, this should be about ready. Okay. Okay, there we go. As is typically the case, the item recommendation, because it's including both a user ID and an item ID that they're looking at, it's including both. It's typically higher than our L1 scores. So, okay. Well, let's do this now. Let's add user features next. And let's go through, and I'm going to recalculate all of these. I'm going to stick with ratings prediction 2 only. So I'm going to keep this as NA, and now let's choose some user features. So those come from donors and that table only. So that's why I left my projects over here a bit. It's because I want to fit this one in right here. And let's grab a select columns pill to pick some, and let's pull it down into train and into score. So here's our options. Donor ID we have to use, and it has to be named the same thing as the user identifier here in the donations table or in the triple, and it is, so we're fine there. It's called donor ID in the other one. However, here's our other options: city, state, is teacher, and zip. I'm going to scope the location stuff out of here for now. Is teacher I like a lot, because research has shown that teachers, even though they make very little, are the largest donors to their own class by a long shot. I remember that being very shocking to me as a parent when I learned that my teachers were spending their own money a whole lot more than I was, and that made me start donating a lot to websites like this a lot more, which is a good thing. Anyway, it's useful to know that if someone's donating more, by including this field, we're controlling for the fact that they're a teacher. And it's going to help improve the accuracy of our recommendations by keeping track of that characteristic. So let's check the box, and it's going to automatically bring, and since that's our only feature that we're bringing in about the user, there's no need for me to test and see what the right combination of variables are, because I've scoped out location for now. That doesn't mean we should, but to keep this example simple, I'm going to, and I'm just going to grab rating prediction. I'm going to grab all my scores. So if you want to pause the video or skip ahead, I'm just going to do this as fast as I can to grab all these new scores again. Okay, actually this is good. I've got an error that came up that is good to talk about. Features for this user are required but not provided. That means that I've got people in this donations table that don't exist here in the donors table. How do I handle that? Well, I think we need to do another join data, just like we did for projects, and make sure that only those people who are in our donors table are also included. So I'm going to copy this and paste it. Come on, copy, paste. No? Copy, paste. There we go. And I'm going to daisy chain these together and say I only want records to come through from here when there's a matching record in this data set. So I'm going to tell it, double click, only include donations for donors that exist in the table. Okay. That way I won't have that error again, where it says I've got a donation here for somebody who's not there in the donors table. Now this is changing the data set that's being used in here. And so as a result, it would actually be wise to go back and recalculate all of the scores in this table, because they're going to change now that I'm working off of a different data set. And I think, oh, that's a pain, I don't want to. Yes, it is a pain, but we got to do it anyway. So what I'm going to do is let's update this. We're including the donor is teacher filled. And I'm going to go through and recalculate all these numbers and all the rest of these same numbers but actually I think I'll stick with 2 here. I'm going to redo just these numbers. But then I'm going to add these down here for this one as well. So we're going to fill in those blanks right there with this table, and actually I'm redoing those ones as well. So I'm going to pause the video, and I think you should be comfortable now doing that too. Let's fill in all these numbers. But as usual, I can never get anything right the first time. I got to change it. Project ID was what we left here in this other one. We're combining donor ID to donor ID. So sorry, change these names too. Take out project, add donor, take out project, add donor. Okay, keep it as inner join. Now that should all be happy and work just fine. Okay, so here's what I got. I actually need an extra decimal of precision to show this here. I'm going to, yeah, let's do that right now. Let's increase these to 4 digits. So NDCG score went up, but only by a little bit by including that donor as a teacher. The related users improved a bit across both, but related items actually got a little bit worse. So I think I'm going to keep it overall and just know that doesn't make a huge difference though. But let's now add a new model and let's take a look at some item features. So here's how we're going to do this part. There's a lot of item features to choose from. Let's begin by getting all the data here into one spot. So I've got my project data. However, I also have information about schools, teachers, and resources. I'm not sure if I'm going to use all of them yet. Let's explore them and see what options we have. So the initial project list, we've got all this text about the project. So let's do some text analysis on one of these fields. I think to keep it simple, although you could include all of them, I'm just going to start with project needs statement, I think. And this is going to be very similar to resources, so I think I might scope resources out because this data set is just a list of those things one at a time. Where you get them, here you go. Here's the name of it, the exact item, and the name of where they suggest it gets purchased from. I think to keep this demo a little bit simpler, I'm going to get rid of that and use the needs statement from the project data. But let's take a look at schools and see what we've gotten here to work with. Okay. School lunch percentage, metro type, state, zip, city, county, district. I'm going to keep location still out of this. So I've got metro type and school percentage free lunch. Okay, let's include both of those. Let's see what we have here under teacher. Interesting. Okay, so I've got the teacher prefix, whether it's Mrs., Mr., or Ms. Is there a Miss as well? Nope, those are only 3 options. Oh, and teachers, for those that didn't want to disclose. So let's include those. Now, there aren't a whole lot of features here. If there were, I would set up a regular prediction calculator model and try to predict donation amount from a combination of all the different features, and then I'd use permutation feature importance to determine what the most important features are. But since I don't have a lot of features, I'm just going to go ahead and include all of them. So here's what we need to do. Let's grab a couple of join datas to put these together. So I'm going to move this one right here and say let's grab from our, so this schools has and teachers have the primary keys. The project table had the foreign key. So what I'm doing is I'm going to tell project ID, no, school ID from the projects table and school ID from the schools table. Now, because I'm using the join data pill, those 2 primary key, foreign key names don't have to be the same because this pill is specifying which ones go together. Then I'm going to grab another join data and say bring this together again, and this time let's join teachers to, so now I've got, before I get to this point, this is resulting in a data set of all the project data and all the school data. And actually we should say I don't want the primary key, I don't need that repeated. So now let's join the combination of those 2 to teachers in this pill by saying now use the teacher ID from the left side with teacher ID from the right side. Again, don't keep both the primary key and the foreign key. All right, with that, now what I want to do is a select columns to choose only those that I want included. But let me run it to this point so that it just shows me what I have available. I'll leave it recording. This should only take a second. So notice though that because I have this partition and sample, which let's see, first of all, no, right here, this goes over to a join data. That means, all right, that means I've still got everything coming out of my partition and sample pill, regardless of whether or not it includes a donation coming down through here. So some of these may not be relevant, but that's okay. It won't hurt us to have them. But I've got a total of a little over 5,000 records coming through. So if I ever want to change my entire project to include more data, because if you look down here, you'll see that we're only including, after we remove those that don't have a project, oh, I got to run it. I think we're down to something like 4,000 donations coming through down here. So we could increase that by bumping up partition and sampling up to something higher than 12%. But everything coming out of here is valid to pull in because it's okay to have projects here that don't have a donation matching. I just can't have a donation that doesn't have a project matching. So let's add in now a select columns next, and let's choose what we want to include. So let me pull these out and start over here. First, we're definitely going to need the project ID, and that's got to be named the same as the foreign key over in the donations table. From the teachers, all right. Oh, here we go. Teacher posted project sequence. Now, let's see. Yours might be in a different order than mine because I did a little bit of messing around when the video wasn't recording. But you've got this probably shows up later. So let me pull that in and pull it back out so it looks more like no, it still wants to put it there. Anyway, if yours is right here, teacher posted project sequence. This could be useful. It just says where that project appeared on a page. Project type. Yeah, let's grab that one. Title, essay, all the way down through here. These are all fields that we could do text analytics on. I'm going to use just the need statement, but in reality, if I wasn't doing this, I'm trying to keep the video as short as I can, but in reality, I would try all those. I'm just going to clean up that one, though. Subject category tree or subcategory, that could be useful. I wouldn't use both of them. I'd pick one because they're both referring to the same thing. This one's just at a higher level, and this one's more granular. So I'd pick one of them and then try the other one and see how it's different. Grade level, sure. Resource category, yeah. Cost, definitely. I'm not going to worry about the dates. I don't think that's going to have as big of an effect. Metro type of the school, yeah, they rural or urban. % with free lunch. I think there might be a lot of missing data from that field, but I can't remember. Let's grab it for now. We might get rid of it later. And then teacher first posted project date. That could be useful because that indicates how long they've been posting projects to donors choose. But what I would do is I would create another field that I would say years since their first project. So a greater number of years means more likely to write up a better project report. But I'm going to scope that out for now and just use these. Okay. Next, let's analyze the text in that project needs statement that I included. So let's start with the pre-process. And let's pull that in and just apply that to column name, need statement, that one only. And let's run it to that point. Okay, that was way faster than I anticipated. Let's check and see how many records we're getting out. Oh, we still have 5,000 rows. That's pretty good. So let's see what it probably created something right here. Pre-processed project need statement. So here's the removing stop words. Here's the original statement. That looks good. So now let's run an LDA on it and turn that into topics and see what topics are useful in improving our recommender. So I'm not sure. I think I'm going to start with 10 topics. Ideally, we'd go and mess with this and try a variety of numbers, as you've learned from prior videos. I'll say 4 words together, 4 grams and below are what I want to look for. Let's tell it which field that we want to run this on. Not everything, just on pre-processed need statement. Once that runs, let's do a select columns. Come on, copy, paste. And in this one, let's remove the stuff we don't need once the LDA is done running. So we're going to tell it, no, I don't want all that stuff. What I want it to do is start with all columns and exclude the pre-processed need statement and the original need statement. Send everything else, including the 10 topics that it's going to come up with, that's going to hash out from here. Send that and everything else through to the Matchbox recommender, but not the original text or the pre-processed text, because that's just going to clog things up. So let's pull this in here, and let's start with our rating prediction and go through our process. So run selected. While that's running, I'm going to come back here and find an efficient way to record everything that I'm trying. So I think rather than list out all the variables, I'm going to say list 1 here and create list 1 right here. List 1, this is item features. So I'll come back here, select columns is done running, visualize. Oh, no, that's not what I want. Well, that would work. I just need to say that these are all of the fields that I'm including. Copy. Let's go back here. Paste. Does that work? Yeah, but now we have to do a copy, paste, transpose. Where is that at? Right there. Let's do a format painter. Put them in the same type. Get rid of all this stuff over here. Alright, so list 1. These are the variables I'm trying. So that's how I mark and keep my table clean right here. Alright, let's delete these out of here. We're going to recalculate all of those. Looks like we're almost done, actually. Nice. That LDA, this is running a lot quicker. Oh, I upgraded my account recently, that's why. Looks like that did something. Okay, let's grab our RMSE score. 1.19. I can't remember, did that go up or down? Let's find out. Actually, that got worse. Look at that. Worse when we include that whole list. So that tells me that I'm going to need to go through and find out which one of these to remove. So I'm going to stop this right there. And what I'm going to do instead is save this. And we need to go ahead and create a new experiment to figure out what the proper list should be, or at least give ourselves a better idea. So I'm going to call this the item features list for donorschoose.org. So what I'm going to need now is, actually, you know what I can do to save myself some time? Let's go back here. Okay, yeah, ignore that. Open this one up again, and let's save as. So I can keep everything in there. This is donorschoose.org. Item features list. Okay, fine. Lowercase. All right, cool. So this is saved a copy now, and I want to get rid of everything I don't need, which means I need all these data sets so that I still am only working off of the data that I want. But what we're going to do now instead, we're predicting, all right, let me think through this. Rather than a train Matchbox recommender, I want to bring this data back together again into one, but I like all these things that I've gone through to apply a transformation to the data. So here's what I need. I need to add donation back into all this other data. So here's what I'm going to do. We're going to add, I'm going to keep all these, I'm going to copy this, paste it. This might be overly complicated. I hope not too bad. Join that data to this data. Because I think we now have at this point project ID over here. Yes, so what we can do is, because we still have project ID coming out over here. Yeah, that's what I'm going to do. I'm going to move all this down here. Join data right there. This is getting, I know it's getting pretty big and nasty. Maybe what I can do is move this up here to make it a bit simpler. Okay, so I've taken my features data set over here and my item triple over here, and I want to join it based on project ID. So I'm going to say, rather than join on donor ID, join on project ID. Oops, come on. There we go. This one, I should also have a project ID over here. Whoops. There it is. Check. But I've also got all the topics now that are coming out of my LDA. I'm now applying my SQL transformation just like I was before on the donation amount. I'm going to change my split data now to a regular split rows. And now it's time to pull in a regular old train model. Score model. Okay, and what we want to predict here is the amount donated. So donation, it's a calculated field, which I'm going to have to recreate. We called it right here, donation amount. So let me select something else for now, just because I got to get rid of that red value required. But I'm going to change this in just a minute. Donation amount. Let's pick. Let's grab an evaluate model, not recommender in this case. Okay, and to predict a number, a whole integer, I'm going to try the Poisson. But ideally, you'd try a few of them out. I'm just going to stick with one for now. So I want to run, actually I only want to run up through edit metadata, because that's going to generate the new field called donation amount that is natural log transformed and then rounded to the nearest integer. But I can't select that in my trained model until it's generated here in edit metadata. So I've just got to let that run. So I'll pause this while it gets to that point. Okay, that one's finished running. So now my trained model, instead of that old original donation amount, I want to predict this new version I have, donation amount right here, the transformed one, because then I'll get a more accurate assessment of how each variable is influencing it. This should actually run pretty quick, because I think we only have, let me see, once it changes screens here, I think we only have about 4,000. What was that record set again? Yeah, 4,300. So the reason why this has gone down, because we had 5,000 projects coming through, we told it to only include donations that have matching projects, but we also said only include donations that have teachers that exist in the donors table right here. That's what this join data is doing. This says only include live projects, and this one says only include those that show up in the teachers donors table. So that's why we have a fewer number of records down here. So let's see what we got. Almost 20% R squared. Okay, so these variables that we have coming through right here are explaining 20% of the variance and how much each donation was. Where's our donation? Oh, it's tied in down below. So what I want to do now is let's grab a permutation feature importance, pull it off this trained model. Oops, right there. And then this is the test data right there. And let's find out which variables we should be getting rid of to try and improve this model. And like I always do, make sure you change this. First of all, let's get ourselves a random seed. But we want to use, this is a regression model. We're predicting a number, not a classification model. Make sure we change this down to R squared before running this. All right, let's see what we got here. Okay, oh, what did I do? Only project ID and donor ID are coming through. What am I missing here? I'm only letting something through. Let's take a look here. Split metadata. Oh, somehow oh, that's why. I must have a select columns here. Oh, my apply SQL transformation. Remember how I told it to only select those? Yeah, I need to, I think in this case, I'm going to, yeah, I still need everything else to come through, so I think what I'll do is eliminate this for now in this model and not worry about that. What was happening is all those fields that were coming through from our LDA and everything else were getting eliminated in that apply SQL transformation because it was only selecting those 3 fields. And we don't want that. We want, yeah, we want to control for those things, but we want all those fields to come through. So this just means that it's going to be analyzing. It won't combine donations. And there's ways around that, but I think for purpose of what we're doing, I'm going to say that's good enough. So let me just rerun this now. And of course, looks like that means I've got to change this. Now that I'm not applying the SQL transformation, it's not going to be called sum donation amount anymore. It's simply going to be called donation amount. There we go. Check. Let's just double check everything else so I don't have to do this again. Yep, change this one. Edit metadata. Also going to be donation amount. It renames the donation amount. That's fine. Okay, I think we're good there. Let's run this again. Okay, so let's take a look here. Feature importance. All right, donor as teacher matters quite a bit. Oh, I got to get rid of the spare donor ID. That's a mistake. But give me the same one for both of them. That's fine. So keeping track of controlling for donor in school, that's irrelevant because we have to include those anyway. What I really want to know, though, is about these. Donation included, optional donation. That's interesting, useful. A lot of my topics are showing up way down here. You know, I got some project IDs and duplicates of all of them that I need to get rid of. Let's figure out why that's happening real quick. So it's because I'm rejoining all of this back over here, and I didn't eliminate the project data that was coming out from this side. So I think I need to go ahead and add one more select columns. Yeah. Well, okay, I know I'm getting a little messy here. Let's put it down. We can do it just right here. Copy, paste. All right, let's get rid of stuff we don't need. We're going to begin with no columns, or let's just go by name right here. So project ID once, donation ID we don't need, donor ID yes, because we'll control for the person in the project. We do want these, don't want that ID or any of those IDs. We do want that. No, we want this one. Because these are, I'm grabbing all the possible ones that we can include and controlling for donor and project. This is our dependent variable, but everything else I've got here are the items we were including previously. Like cost, grade level, resource category, yep. Current status, fully funded, donor is teacher, yep, grab that one. We've got, I think the rest of these are duplicates. What we do need is school, metro, free lunch, yes. And then our 10 topics. Yeah, it might have been better to do the remove items. Yeah, I think I like that better. Let's do this. Let's grab a, I'm going to move this one over here instead. And let's do this as a remove instead of as a select. And that simplifies things a little bit nicer. So let's pull this one up and say exclude the things we say here. Perfect. We want all of these that are number 2. Okay, donation ID, we don't need that one. Regular ID, school ID, teacher ID, that might be useful to keep track of as controls, kind of like project ID and donor ID. So I'm going to keep those in there, but I don't want donation ID because each individual record's donation ID is different. Same with ID here for the projects. So let's get rid of project title, essay, short description. We're keeping needs statement. Well, not at this point anymore, no. Oh, but it says it's already not included at this point. I think it is. No, but not the original one. The 2 is. Okay. Subcategory. We're going to keep subject category, but not subcategory. Grade level resource. We'll keep all those. Posted date. Expiration date. Current status. Funded date. Those are all irrelevant. Donor ID 2, yeah, we don't need any of those. Let's keep donor as teacher, school, metro type, school, lunch. Pre-processed needs statement, get rid of that one. But it thinks we've already gotten rid of it at this point. I don't think we have. I think we need to get rid of that and needs statement. Oops, not short description. Unless it's going to complain at us, I might have to get rid of those later. Okay, I think that's it because we want to keep all these topics. And we want to keep the rest of those. Let's give that a shot and see what it says. Nope, it's going to force me to get rid of them. Here's what's going to happen. It just needs to refresh. So I'm going to have to run it up to that point, and then I can fix it. Okay, now that I've run up to that column, I think it's going to now let me begin with all columns and exclude. There we go. I think I should be able to get rid of the need statement. No, it still doesn't like it. Okay, so maybe it's happy where it's at. But how has it already gotten rid of those? Well, let's see what's coming out of here. Let's do visualize results data set. Okay, so we get the project donor, donation amount, that's our dependent variable, includes optional information. Oh, you know what? We don't have that in our other data set. We're going to need to get rid of that one. Or included, even better. Alright, so school ID, teacher ID, yep, this looks right. Oh, I got that project ID 3 I got to get rid of. And then all these 2s are coming through still. How did I miss those? Metro type, topics, that's right. But I'm not getting pre-processed need statement or need statement, so that's correct. But I got to get rid of all those other 2s in there. Let's grab this and say, yep, down here. Did I have it? Oh, there's donor ID 2. So project ID 3. That one. All these down here that have the, where I've doubled it up. Need statement 2. Subject category tree 2. Grade level 2. Resource category 2. Cost 2. Okay. Alright, let's give that one a shot. As you can see, this gets a little bit complicated. especially when you're using these multiple select columns to try and get rid of or keep all the stuff that you want coming through. All right, let's see what we got now. Results data set. Yep, good. Good. Cost owners teacher. Beautiful. So these are all the things that I could potentially use back there in my Matchbox recommender. And now let's see how important they end up being. Okay, let's take a look here. First of all, let's see what kind of model improvement we got now that we've added all these other variables. Okay, cool. So we went from 20% up to 34, almost 35% R squared. That's really good. Let's take a look at permutation feature importance here and see which ones we should get rid of. All right. Look at all these topics down here. Few of the topics made a difference at all. And those that did are actually, oh, we need to get rid of donation received date. And those that did are still pretty low. I don't see any topics that are really high. Donor as a teacher matters a lot. These IDs, these controls matter a lot, but we have those anyways. So it's not like I just kept these in here so that I could get a better idea of how much everything else matters. Teacher posted sequence matters. Cart sequence matters. But this is the donor cart sequence. See, we need to include that that variable. We weren't including that before. Donation includes optional amount. That seems to matter. Project cost. Yeah, I think let's start by, let's get rid of donation received date. Let's tune down the number of topics to maybe like 3, 4. And let's run this one more time and see if that gets any better. So LDA, I'm going to go down to 3 topics and maybe even fewer n-grams. And then let's get rid of that project date that we hadn't gotten rid of before. Let's see here. Exclude. See, once the join breaks, because I changed some things up above it, it loses all of these. Donation received date. I think I want to get rid of that one. Oh, but it won't let me make that change. It's got to run the whole thing again. All right, no problem. Let's let this run, and then I'll get rid of the received date. All right, let's see what happened to our R squared. Actually, that went down. Quite a bit went down. Let's see what it did here to the importance of our variables. I mean, it went down from like 39% to 34%. Our topics were still not particularly useful, though, which is interesting. It still did better when we had more topics, but none of them were coming through in the permutation feature importance. So, all right, I got to keep this video from getting too long. Basically, this is a process that could take a while as we go through and try all different types of feature hashing and all those things. Project type continues to be small and not matter a whole lot. Project posted date, is that one still on here? Do we get rid of that? Donation received date, that's the one I got to get rid of. So here's what I'm going to do. I am going to take the things I've learned. I'm going to come back here to my... The idea is we learn from a regular prediction calculator about which features matter. And then we can come back here to our recommender and apply that. It looked to me like it was actually better to keep more topics. However, knowing that the need statement didn't help a whole lot, I might come back here and say, let's change, and instead of analyzing the need statement, let's go ahead and grab a short description of the whole project. Check. That means pre-processed text. We're now doing this based on short description. There it is. I'm going to have to change this to, well, I can't change it until I run pre-processed text. But there was some information about the donation that wasn't being pulled over here into well, that's okay. I wasn't pulling in. This is only for features, item features, and that those donation characteristics weren't based on the item features. So I'm going to remove. First I got to run to that point. So let's do that. Let's run selected so I can get our pre-processed text based on the adjustments we made to our we're going to make to our LDA. Okay, so now here in my LDA I can say it's not pre-processed need statement, it's pre-processed short description. And I also want to get rid of project cost, because back in my prediction calculator, that wasn't doing me any good. In fact, it was only hurting it. So I am getting rid of, also, at this point, I'm going to get rid of project cost, the short description, and the pre-processed short description. And I'm going to go ahead and keep all the rest unselected. Okay, so when that's done, I'm going to come over here to Excel and say, I ran all this again. Well, I haven't. And hopefully we're going to get a better RMSE here. And instead of list 1, I now have list 2, which instead of those features includes no more project cost. And instead of need statement, I have project short description. I might just highlight these are the differences between the two. And maybe I'll pull this one back down there. Make these both a little bit bigger. See the difference. Oh, oops, and change that one to list 2. So here's our primary differences between them. And here's me documenting the difference that it's going to make. We're going to find out right here in just a second. Let's head back over here. All right, still in scoring mode, and I'm still in reading prediction. Perfect. Okay. All right, looks like it didn't change it a whole lot. And I think a lot of this has to do, honestly, whoops, that's not what I mean to do. Right there. Did it change it all? No, basically the same. So this getting higher by including item features, usually it doesn't get higher, it actually gets lower. And I think the reason to do is because we turned down our traits so far down to only 2. And that may not necessarily be a wise thing to do, because it's going to force everyone to the same projects, and I'm kind of going back and forth on whether or not that's worth it. But what I'm hoping you get from this video is the process and my thinking as I go through the process. There's some hard and fast rules, and there's some business decisions, like number of traits to use. But I'm learning the whole time about how my features are adding to or hurting the effect of the core item triplet and coming up with a product recommendation. So I'm going to stop here for now on this video, but I am going to make a follow-up video next on how to implement the 3 different scoring options in an actual web service for this, if you want to follow along with that too.